All right, in this tutorial, we're going to briefly look at how to determine molecular polarity. Now, before you watch this video, you should already be familiar with the idea of a polar molecule being a molecule that has a separation of charge. You also should be able to determine the three-dimensional shape of a molecule and predict if the molecule contains polar bonds or nonpolar bonds. So we know from some previous learning that in order to be a polar molecule, a molecule must contain a polar bond and have partial charges, and it has to have a non-symmetrical geometry. So I'm just going to walk you through how to determine if a molecule is polar or nonpolar. So the first example we're going to look at is pretty straightforward, just hydrochloric acid. So you have to have an idea of what the three-dimensional geometry of the molecule is going to be. So that means you either need to draw out what it would look like in 3D or its Lewis structure. So I'm just going to draw our HCl. And then I'm going to check to see if my molecule meets the criteria for a polar bond. So my first check is to be a polar molecule. My first check is, does it meet the criteria of having a polar bond? So I'm going to look at the electronegativity values of these atoms. Our hydrogen has a 2.1 and our chlorine is a 3.0. So that means the electronegativity difference between these two is 0.9. And that meets the criteria for a polar bond. So that means that our hydrogen and our chlorines have a partial charge. So our hydrogen gets a partial positive and our chlorine gets a partial negative. The next thing we have to do is check and see if it meets the non-symmetrical criteria. So we're looking at its shape. This is pretty easy to realize that the HCl is non-symmetrical. If we looked for the center of all the positives, we're going to find it right here on our hydrogen. And if we looked for the center of all the negatives, the only spot of negative it exists is on this chlorine. So if we look, we can see that there is a separation of charge or a magnet. So we have a magnet, and we have that magnet because it's non-symmetrical. When you are figuring out if a molecule meets the shape criteria, you have two options for your approach. Your first approach is that you can memorize which molecular shapes are non-symmetrical. The other option is that you can, by case-by-case basis, look for a magnet. And I've shown you both of them right here. Okay, let's do another example. Let's do the example of we're going to do PCl3. So I'm going to draw the Lewis structure. You should be able to draw the Lewis structures of these compounds by now pretty quickly. So I'm going to draw the Lewis structure, and then I'm going to look for my bond. So my bond check, my chlorine has electronegativity value of 3.0. So all of these are 3.0. And my phosphorus has electronegativity value of 2.1. So we have a difference, again, of 0.9. So that meets the criteria for a polar bond. So it meets that criteria. And so we know we have partial charges. So my chlorines become partially negatively charged. My phosphorus becomes partially positively charged. So because you met the bond check, you now have to check your shape. So you have two options. You can have memorized if it's the trigonal pyramidal, is non-symmetrical or symmetrical. And if you've done that, you know that the trigonal pyramidal is non-symmetrical. Or you can look for your magnet. If you look for the center of positive charge, it's going to be directly on top of the phosphorus because that's the only positively charged ion that exists. But the center of negative charge is not on top of the phosphorus because we've just drawn our Lewis structure here. But if we drew this three-dimensionally, how we would draw our shape, it would look like this. So our center of positive, I need to get my lone pairs here. There we go. They're important. My center of positive charge is right on top of my phosphorus. But this is a pyramidal shape. So the center negative is actually directly below the phosphorus. They're not in the same place. And so this trigonal pyramidal has a magnet. And it has a non-symmetrical shape. So this one meets the criteria. I actually forgot. So this here is a polar molecule. And I didn't even label the HCl up here. It's also polar. All right. Let's do another one. Let's look at this time we're going to look at NCl3. I'm going to draw my Lewis structure of NCl3 using what I know about how to draw my Lewis structures. I end up with something that looks like this. Then I'm going to do my bond check. So my nitrogen has an electronegativity value of 3.0, and my chlorine has electronegativity value of 3.0. So my bond, my electronegativity difference is 0. So this molecule does not pass the bond check. Because it has to have partial charges from a polar bond to be a polar molecule, this is a non-polar molecule. I don't even have to look at my shape because it does not pass the bond check. We're going to do one more. We're going to look at not Cl. We're going to look at CF4. So if I drew my Lewis structure and I followed all the rules, my Lewis structure is going to look like this. Okay. So we know that this has a central atom with 4 things around it, so it's a tetrahedral shape. So we can start off and we can look at our bonds. So fluorine has an electronegativity value of 4.0. Carbon has an electronegativity value of 2.5. So my difference is 1.5. So we pass the polar bond check. We're going to have partial charges, so we have to write those in. And now we have to look for our symmetry. The tetrahedral, if you look at your list, is always symmetrical. So without even looking for a magnet, I can know that my tetrahedral shape is never going to give me a polar molecule, because when we look at it, it's completely symmetrical. I can look for a magnet, and I can find my center of positive on top of my carbon. And if I find where all the negatives meet, it's going to be directly in the same spot. So there's no magnet. Just write magnet X. So this molecule passes the bond check, but it does not pass the shape check. So this is another example of a non-polar molecule. So when you are determining if a molecule is going to be polar or not, you essentially want to walk yourself through this checkpoint. You want to just go and look for partial charges. If you don't have any partial charges, your molecule cannot be polar. If you have partial charges, look at the shape. Is the shape symmetrical? And remember, you have to consider the three-dimensional geometry, not just the Lewis structure. Okay. So I want you to do some practice of this, and then we will do some together in class as well.